All right, hi everybody. What in the world was all that about, huh? Well, just having some fun. It wasn't random. Um, Let me just clear some things off here. So what is this? I started off with some points dancing around, then I had them drawing stuff, then I showed all of these lines. Hey, oh, it's still tracing. I didn't want it to trace anymore. Erase. Let's see here. So anyway, I was just having fun with our Euler's lab and our Euler's line. This is the construction that we did when we found the circumcenter, centroid, orthocenter, and then we threw the incenter in there. And when I started with just those points, it was all the intersections. So you can see how you can take a construction like we did together and have some fun with it. Okay? I know oftentimes when I do something like this, students will say, man, it almost looks like a computer screensaver or something like that. Yeah. How do you think that stuff's made? Using math. Pretty cool. All right, let me get out of there. Now, what we're going to be looking at today is relationships within triangles, relationships between their sides and their angles, and then relationships just between the sides themselves. So let's take a look at this one together. Okay, and what I want you to notice here, I want you to draw in, oh, you like my Christmas tie, by the way, is the lengths of the sides compared to the lengths of the angles. So if we look at this triangle, I hope you would agree with me that this is the shortest side. This is the longest side. Okay. And then when we look at the angles, what do I notice here? I notice that this is the smallest angle and this is the largest angle, and we should see a relationship. Okay, we should notice that the shortest side is opposite the smallest angle, and the largest side is opposite, or the largest angle is opposite the longest side, that they're across from each other. And does that, intuitively make sense? So I got some straws here. Okay, can you see them all right? If these are two sides of a triangle, okay, and look at that angle that's formed right here by my fingers. Okay, what happens as I make that angle bigger? Imagine that there was a side connecting these. What happens to the length of that side? As the angle gets bigger, the side opposite it would get larger, wouldn't it? Okay, and the reverse is true. As that angle gets smaller, if there was a side connecting those 2 points, that side would get shorter and shorter, wouldn't it? Okay. So, does it make sense for us that the shortest side is opposite the smallest angle? That the longest side is opposite the largest angle? I would hope that that would make sense for us. Okay, and that's what I have here in these two theorems. It's a little bit more than that because it starts comparing the sides to each other. So let's see what this says. If one side of a triangle is longer than another side, look at this. 8 is bigger than 5. So AB, that side, is longer than BC. Now that tells us something about the angles. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So what do I know here about my angles? Which side is opposite AB? Angle C. Well, because AB is longer than BC, angle C, this should be the measure of angle C has to be greater than, well, what angle's opposite BC here? A is. So the measure of angle C has to be greater than the measure of angle A. This side's longer than that side, so the angle opposite that side has to be bigger than the angle opposite that one. Okay. Now, what does this tell us? If one angle of a triangle is larger than an angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Okay, it's the converse. We're just switching it here. Notice angle A is bigger than angle C. Okay. Measure of angle A greater than the measure of angle C. What's that tell me about side lengths as I compare them? What sides opposite our bigger angle? BC. So BC has to be greater than what sides opposite our smaller angle? AB. So we have this relationship. If we can look at the relationship between two angles, we can determine the relationship between their opposite sides. If we know the relationship between the two side lengths, we can figure out what the relationship is between their opposite angles. Okay. Now let's take a look at a situation here where we have some information. We're going to have to piece together the rest of the information. A long-tail boat leaves a dock. Okay, long-tail boat. Are you guys familiar with long-tail boats? Okay. I thought maybe a couple of you would be, but figured most of you wouldn't. Hey, here's a long-tail boat. Okay, kind of native to the Southeast Asia area. You can see why it's called a long-tail boat. Typically what happens is they attach a propeller, a boat motor, to some sort of like car engine, something like that, and they extend it way out there. If you're a duck hunter in the area, sometimes you'll see these long-tail kind of motors on duck boats. They're used so that you can drive in very shallow water. You can lift that propeller up. So it's usually a decent sized boat. Okay. Oftentimes there's some makeshift structures on here. Notice they put a little canopy, and then they take this car engine and then they extend this long tail. So that's what we're driving around here. Okay, so we've got this long tail boat. Okay. It leaves the dock and travels 2,500 feet to a cave, 5,000 feet to a beach, and 6,000 feet back to the dock. One angle is 55 degrees and another angle is 24 degrees. What is the angle measure of the path made at the cave? All right. Man, it almost feels like there's not enough information to figure this out, but in fact there is. So what do we have? We have 3 side lengths. I think maybe drawing a picture here would help us out. So, let's see here. Leaves a dock. So let's say the dock is right there. Travels 2,500 feet to the cave. They didn't give directions. I'm just going to go a certain distance here. I'm going to say that's the cave. So this distance is 2,500 feet. Now from there it goes 5,000 feet to a beach and then 6,000 feet to get back to the dock. So let me think about that here. I've got to go 5,000 feet somewhere to a beach, and then my distance from the beach back to the dock has to be a little bit longer than that. So I don't know. Let's go maybe here. This is a sketch. I'm kind of guessing on where it is here. And we'll have to figure out some more things. So let's say that this then is the beach. So this is 5,000 feet. And then from the beach back to the dock is 6,000 feet. Okay, this is not drawn to scale. I'm just sketching a triangle here, trying to figure things out. Now, we have 2 angles. We were told one angle is 55 degrees and one angle is 24 degrees. Okay. Now, thinking about what we just talked about, we know the side lengths. Which side is the longest side? Well, this 6,000 feet is the longest side. What does that tell us? Well, we know the longest side is opposite the largest angle, isn't it? This angle is the biggest angle. Okay. So we've got one angle is 55 degrees, one's 24. The bigger angle here is 55 degrees, right? Not quite. Okay. We're missing a piece of information that's helpful to have here. What piece of information are we missing? We know all 3 side lengths. We only know 2 angle measures. Can we figure out what that last angle measure is? 180 minus 55 minus 24. Let's see here. That would be 79. 180 minus 101 degrees. So what angle is opposite the longest side? This angle right here of 101 degrees. Okay. What angle measure of the path is made at the cave? 101 degree angle. Now, can we figure out what the other two angles are? Let's finish this. Let's be thorough. Okay. Let's see here. We've got the beach and we've got the dock. Notice this side is our shortest side, isn't it? Our shortest side is opposite our smallest angle. So the angle formed at the beach has to be the smallest angle. Well, we already did 101. We've got 55 and 24 left. That has to be 24, which means this angle is 55 degrees. So again, the relationship between the sides helped us figure out the relationship between the angles. The side was the longest. That's got to be the biggest angle. This side's the shortest. That has to be the smallest angle. So just like that, okay, we're able to figure out what the angle at the cave is. So take a look at this one. Okay, order the sides from shortest to longest. Well, we know angle measures. Okay, do we know the relationship between these angle measures? Yep. Shortest to longest. So shortest side is going to be opposite the smallest angle. Our smallest angle is 45 degrees. So our shortest side is QR. Let's see here. What else? 80 degrees. That's the biggest angle, isn't it? So it's opposite the longest side. PR is the longest side. Which means what side is the middle length? Well, we did QR is the shortest, PR is the longest, PQ would be the middle of those side lengths. So from shortest to longest, QR, PQ, PR. All right. Now, that's important to know. But this next thing is also quite important, and it's the main thing I want us to be able to pull out of today, is will any three side lengths make a triangle? How would we know? So, going back to some straws here. I have 3 straws, okay, and my question is, can I make a triangle with these 3 straws? What do you think? Try to hold this still enough. Do you think I can? Well, let me show it to you this way here. Can I make a triangle with these 3 side lengths? Some of you might be saying yes, some of you might be saying no. We're not together here in person, so we can't talk about it, so let me try to demonstrate this. Usually when I'm trying to figure out if 3 side lengths make a triangle, I usually like to put the longest on the bottom. For whatever reason that makes sense visually to me. I'm going to put this one right there. So I've got my longest side on the bottom. I've got this side. I'm going to put it right there so it's almost like a hinge. Okay? So this side is going to go somewhere here. Now where does this last side have to connect? Well, it's got to go over here, doesn't it? And it's going to hinge this way. Okay? So it's going to go somewhere there. If I'm going to make a triangle, what needs to happen? I need these 2 straws to hinge and come together. But notice, what are you seeing here? They can't touch each other. They can't reach each other. Okay? Now let me switch out this one for this one. Okay? Do these 3 make a triangle? Again, I'm going to put one here to hinge. I'm going to put one here to hinge. As I bring them together, are these going to make a triangle? Yeah, they do. Right there. They come together. They connect. So what's the difference between our first situation of these 3 and the situation between those 3? How can I tell that difference? How can I tell if it's possible to make a triangle or not? Well, let me use GeoGebra here as another visual. Let's see here. I am going to go here. I'm going to make a segment across the bottom. Now, going back to this, remember I put this one piece on here so I could hinge it, so it could rotate. In other words, this is going to travel along and make a what? It's going to make a circle, isn't it? So what I'm going to do is I am going to, let's see, here's my circles. I'm going to make a circle here. And I'm going to put my next side length to go somewhere on this circle. So it can go anywhere right here. I'm going to do the same thing on the other side for this side length. So this side, anywhere there. Are these three side lengths going to make a triangle? Are they going to come together and connect? No, they're not, are they? They're not going to connect. Okay. Why? Well, those circles don't intersect, do they? What's going to make those circles intersect? Well, if I made them a little bit bigger, okay, are they going to make a triangle now? Yeah, the circles intersect right there. So what is the relationship here that I'm looking for? Let's go back to this. This didn't work. Why not? Okay, do you notice that the length of this segment and the length of that segment, that combined length is not longer than AB, the third side? Okay. Going back to my straws, it's kind of small down here in the bottom corner, but when I put these two straws together, that combined length is not longer than that longest side, is it? So of course they're not going to be able to reach each other. The only way that we can make a triangle is if the two sides, their lengths add to be longer than the third side. The sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. Otherwise, they're not going to come together, they're not going to connect. I wonder why I have a second image of myself here. That's kind of strange. I don't like that. Let's do this. There we go. So the sum of the lengths of any two sides of a triangle has to be greater than the third length. Otherwise, those other two sides, they can't reach each other. They can't make a triangle. So I've got three situations here. I want to know, is it possible to make a triangle with these three side lengths? 2, 5, and 2. Well, let's head back to GeoGebra here. I'm first going to make, oh, come on. GeoGebra is not working right now. All right, we're not going to use GeoGebra. Okay, we're going to just draw a picture. My side lengths are what? 2, 5, and 2. So let's picture this. If the bottom was 5, one side was 2, and the other side was 2, are we going to be able to make a triangle? Okay. As we rotate these, as these hinge, are they going to connect as they rotate down? Okay. They're not, are they? They're not going to. These two sides have to add to be greater than that side. Okay. The answer to this is no. 2 plus 2 is less than 5. It's not going to work. How about 13, 12, and 20? Let's say that's 13. Wait, no, let's go. 13, 12, 20. 20 was the longest. Let's put 20 down here. That's 20. 13, that's going to be over halfway, isn't it? And then we're going to have 12. Are these going to be able to connect? 13 and 12 if the bottom's 20. Well, is 13 plus 12 more than 20? Yeah, they're going to come together. They're going to connect, and they're going to make a triangle. How about 6, 6, and 7? Are those going to make a triangle? Put 7 on the bottom. Let's say this is 6 then. Let's say this is 6. Are those going to connect? They're going to reach each other? Yes, they will. So, okay, two sides I always have to add to be longer than the third. Okay. Do these work? Well, let's put them together. Do these two sides add to be longer than that? Ooh, interesting. I'll have to think about that for a second. What do I do about this case? Is that going to make a triangle? Let me add one more example into this. What if I had side lengths of 2, 4, and 6? Is that going to make a triangle? Let's say that's 6. Let's say that's 2. And let's say that's 4. What's going to happen here? Well, this is going to hinge this way. This is going to hinge this way. Where are they going to meet? Right there. Does that make a triangle? No. Okay. The 2 plus 4 has to be greater than 6. If it's equal to 6, it does not work. Alright, so last example here, if I can find where it went. There it is. Okay. A triangle has one side length of 14 and another length of 10. Describe the possible lengths of the third side. So I tell you, okay, we know one side length. We know a second side length. If I'm going to make a triangle, what are the possible lengths of the third side? So as we take a look at this, well, that would make a triangle. Picture that third side connecting those two. Okay, it can go from being fairly short to fairly long. There's a range here. Well, how do we figure this out? Well, my first case, what I'm going to do is I'm going to imagine that 14 is my longest side. Let's make a note here. That's my longest side. Well, if that's the case, I'm going to put my 10 up here. Okay. What value for this side is required to make a triangle if 14 is our longest side? Well, if they're going to make a triangle, they need to meet above that longest side. How big does x have to be? Okay. Well, if you said x has to be greater than 4, you'd be correct. Because we know that these two sides have to add to be more than 14. Otherwise, they're not going to connect. So x plus 10 has to be greater than 14, which tells me x has to be greater than 4. If it was 4, where would they meet? They'd meet right there. Okay. So x has to be greater than 4. That's one situation. The second case, okay, is, well, do we really know that 14 is the longest side? What else could be the longest side? Well, 10 can't be because we know 10 is smaller than 14. Our missing side could be our longest side. So what if this was the x, this is the 10, and that's the 14? How big does x have to be, or how small does x have to be to make a triangle here? If x was 100, would it make a triangle? Would the 10 and the 14 be able to meet? No. Okay, so there's an upper range here. Okay. How about if x was 20? Would that make a triangle? Would the 10 and 14 be able to reach each other if the bottom was 20? Yes, it is. Okay. How about 22? How about 15? Yeah. Okay. What has to be true here? The 10 plus the 14 has to be greater than the x, doesn't it? So in other words, 24 has to be greater than x. X has to be less than, I usually don't like to write it that way, x has to be less than 24. If this was 25, would the 10 and 14 reach? No. So from our first case, where we assumed 14 was the longest side, we figured out that the missing side would have to be bigger than 4. Well, if our missing side's the longest side, we find out that it can't be bigger than 24 or larger, because then the 10 and 14 wouldn't reach. So we end up with a range. The way that we'd like to write this, well, x is greater than 4 but less than 24, the way that we usually write that is 4 is less than x, which is less than 24. That's the range that that missing side has to be in to make a triangle. Okay. So, okay, there we are. We started off with a bit of a dance party. Okay, we learned about the relationships between angles and sides, and then we talked about the relationship between the sides. Okay, I'll catch you next time.